Hi, my name is Scott from the Economics Tutoring Center, and today we're going to do some examples of the exponential distribution. So make sure to check my notation and language use with your professor because it may vary. Okay, so we have a few example problems to work through, and they're all related. So here's our first one. It tells us that a pizzeria gets an average of 4.2 orders in its closing hour, 11 p.m. to midnight. We want to know what is the probability that at least 30 minutes will go by before the next order. So typically when you have an average like this and you want to know about time, so it asks for minutes here, usually that follows an exponential distribution. So in this case it does. And you might ask yourself, okay, what is the exponential distribution? Well, first of all, when the question asks that we want the probability of at least 30 minutes, words like at least or within, that tells you want the cumulative distribution function. And that function is the probability that a random variable x is less than or equal to a specific value of x is equal to 1 minus e to the negative x over lambda. So this lambda here is called a parameter, and the way this distribution function is written, it's the average minutes per order. So the average time for an order, and we're working with minutes. So this lambda, to calculate lambda then, we know that there are, well, we can divide 60 minutes, and we divide that by the average of 4.2 orders. And that tells us that lambda equals, if you do this in your calculator, it's about 14.2857, and that's minutes per order on average. And I'm going to circle this because we're going to need this in the later examples. Sorry, 2857. Okay, so that's what lambda is, and now we can use that to calculate our probability. So we want the probability that x is just a random variable, so I guess time in this case. We want to know the probability that that is greater than or equal to 30. That's what it means by at least 30. And using some basic laws of probability, we know that's 1 minus the probability that x is less than or equal to 30. Because either it's greater than or equal to or it's less than or equal to. So this expression here we can actually use so if you look at the cumulative distribution function again, that's the form we want it in. So we can use that to say that our probability is equal to 1 minus, and then we plug in 30 into the equation. So 1 minus e to the negative 30 over lambda. Again, we know what lambda is. And if you distribute the negative sign, this actually, the 1 minus 1 goes away, and the e becomes positive, so we have e to the negative 30 over 14.29, that's what lambda is approximately. And if you plug that into your calculator, you'll get the probability is 0.1225. So that's our final answer. So now we have a similar example. So we start off with the same pizzeria, still an average of 4.2 orders. And now we want the probability that an order is ready in less than 15 minutes. So again, words like less than tell you want to use the cumulative distribution function. So I'll write that again just to remind us what it is. And sometimes instead of lambda, you'll see a mu. Don't let that confuse you. It means the same thing. But in this problem, we want to solve the probability that x is less than or equal to 15, right? Less than 15 minutes. And so now it's already in the form we want it. So we can plug it directly into the exponential cumulative distribution function. So that's what it would look like. Now lambda is the exact same as it was before because we have the same pizzeria, so it has the same average time per order. So remember that's over here, that was 14.29 approximately. And so we have 1 minus e to the negative 15 over lambda, and if you plug that one into your calculator, you'll get approximately 0.6501. So that's the probability that the order is ready in less than 15 minutes. And finally, we have a third one here. What's the probability that the order is ready between 15 and 30 minutes? We have the same pizzeria again, so we have, okay, so what does that look like? The probability that our random variable x, or the time that the order is ready, it needs to be between 15 and 30. And also using some laws of probability, that's the probability that x is less than or equal to 30, and then we subtract the probability that x is less than or equal to 15. And why is that? Well, if you draw this distribution out, so here's the probability density function of the exponential distribution. Here's our random variable x, which is time in this case. And the exponential PDF looks something like that. So the CDF, it gives you the area under the probability distribution function, PDF. And if we want the area between 15 and 30, what we can do is we take the whole area that's less than 30, and then we just subtract off the area that's less than 15. And what we're left with is this area, and that's exactly what we want. So notice now that both of these terms are in the form we want to use the exponential CDF, which is this one here again. So we can plug those in. So we have that equals 1 minus e to the negative 30 over lambda, and then we subtract 1 minus e to the negative 15 over lambda. And if you do some distribution, this one, and you subtract this one, those cancel out. And then these two negative signs actually counteract, make a positive. So we have that negative e to the negative 30 over lambda, and now we have plus e to the negative 15 over lambda, if you distribute that out. And then again, it's the same pizzeria, same average time per order, so lambda's the same. I just didn't write it into the formula. But if you plug that into your calculator, you should end up getting 0.2275. So those are just 3 common examples that might come up, how to work with the exponential cumulative distribution function. So I hope it helped. so that's all we have today about the exponential distribution. If you have any more questions, feel free to come to the Economics Tutoring Center or ask your professor.